Hello Jess, today you are preparing for the GCE Physics Paper 3 and you are feeling not prepared. Don't worry, because in this video, I will guide you by giving the full correction of the Norway's Regional Number 2026 step by step. So stay until the end because the last tip can save your exam. Hello GCE candidate, welcome back to our YouTube channel School for All. So today we begin with part 1 of our experiment, the Norway's Regional Mock. So part 1 we will do the mainstream. So here you have the full correction of the mainstream step by step. So I will do the table, then follow with the graph. Okay, so for this experiment we need a block, a glass block. This is it. We need a Vernier caliper. We need a protractor to measure the angle. We need a ruler to measure the length. Okay. Without wasting time, let us go to the first step of the procedure. Okay, the first step is use the Vernier caliper to measure the average width of the glass block. Then before measuring the thickness, the width of our glass block, I'll first of all show you how to use these two kinds of Vernier caliper. You see, there's a difference between them. Look at the unit. The scale here is in millimeters, and the scale of the movable, this one is for the first the fixed section of the Vernier caliper. For the movable section, it is 0.05 millimeters. So the 0.05 millimeters here is representing the, let's say, the accuracy of the movable section of the Vernier caliper. It means that any number that you are taking here should be in millimeters. It should represent 2 decimal places in millimeters. Okay, like you are seeing. Let me explain the scale. Here we are having 0, 10, 20, 30, 40, 50. It means it's going 10, 10. It means that in between 10 and 20, here should be 5. So if I want to read, maybe here I will have 10. Here I will have 15, 20, here I will have 25, and so on. Now let us come back to the movable part. Here the movable part we are having 0, 1, 2, 3 up to 10. Okay, so here it means that here should be 0.5, 1, 1.5, 2, 2.5. So as I was saying, the accuracy is 0.05 millimeters. It means that any value that I'm taking here should be in 2 decimal places and in millimeters. Okay, let us move to another type of Vernier caliper. You see that here the difference between this one and the other one is the units at the end here. Here is in centimeters, and also the scale of the fixed part of the multimeter of the Vernier caliper. You are seeing here is 0, 1, 2, 3. It means that in between 0 and 1 there is what? There is 0.5. In between 2 and 3 there is 2.5, and so on. Now for the movable section here, we are having here should be 0, 5, and here 10. So here the accuracy of the movable section here should be 0.05 centimeters. It means that any reading I'm taking here should be in 1 decimal place. Yeah. Okay, now let us measure the width using the 2 Vernier caliper we are having. Starting with this one. This is our glass block. If I want to measure the width, as I was saying, the width is the distance from here to here. The length is the distance from here to here, and the thickness is this one. What we call in French épaisseur, this one. Okay, so if I want to measure the width, I will take it like this. Now make sure it should be here. So there is it. I first of all take the reading of the fixed part of the Vernier caliper. Like I'm seeing here, I'm at 50, 50.1.2.3, 50.55. So pardon, it is 50, 51, 52, 53, 54 up to 55, then 56, 57. Exactly at 57 I should stop, because the movable, the scale of the movable section of the Vernier caliper is starting from there. So I'm having already 57. Now I'm looking for the 2 decimal places. As I was saying, the 2 decimal places will come from the scale of the movable section of the vernier caliper. So I'm having 57 point. Now for us to have the 2 decimal places, you look on the vernier, on the movable part of the vernier caliper where it's aligned with the fixed, where it aligns with the scale of the fixed section of the vernier caliper. We try to see where is it aligning at 3. At 3 here, you see that it's aligning at exactly 3. So it's making my reading to be 57.30 millimeters. Are we understanding what I'm saying? 57.30 millimeters. So that is it. Now let us use the other type of vernier caliper to measure the width, and we verify if they are the same. Now for this one, as I was saying, if you look here, the scale 0 here should be 0.51, 1.5. It means that the fixed part of my vernier caliper is giving me already the value with 1 decimal place. Don't forget it's centimeters. Therefore the movable part should give me the second decimal place lacking, still in centimeters. So I'll place it like this. Okay, now try to, let me fix it. That is it. Now try to see, you are seeing 6, right? Now behind, let's say immediately before 6, we are having 5.5. It should be 5.5. Then 5.5, if it is 5.5, if you go forward, you will have 5.5, 5.6, 5.7. I will stop immediately at 5.7 because the scale of the movable section is starting as from 5.8. So I will stop at 5.7. So 7 is my first decimal place. Now let us locate our second decimal place. You should look where the scale of the movable part aligned with that of the fixed part of the vernier caliper. If you see it aligned exactly at somewhere at 5 or 3 or 5 or 4. In fact, you can choose anyone there. I think it should be 4. It aligns at 4. Yeah, let's say aligns at 4. So it means that my reading will be 5.74 centimeters. So this 4 is giving me the last decimal place of my reading. And don't forget, it's centimeter because the instrument, the unit of the instrument is in centimeters. So you see that if you're taking the first reading of this one, you have 57.3 millimeters. Now if you're taking the reading of this one, you have 5.74 centimeters. You see, if you convert the millimeter to centimeter, you give approximately the same thing, because when you convert from millimeter to centimeter, you're supposed to divide by 10. So if I take 57.3 divided by 10, I will have 5.73 centimeters. So that is it. That's 1 mark. 2, fasten the plain sheet of paper of the wooden board using a thumb tags. They replace the cardboard glass block at the center of the page so that it rests on the larger face. Mark out the outline ABCD of the block on the table until using a pencil as shown below. So we use this A4 paper. With your pencil, you reproduce exactly what is on the cushion paper. So I will form a rectangle like this. Okay. So after this, you name now the vertices of your rectangle. You name the vertices exactly as on the question paper. Here we are having D, here we are having C, here we are having B, and here we are having A. Okay, so step 4, remove the glass block from its outline and mark the point P, which is 3 centimeters from D along the line DC. So you take your metal rule, you measure 3 centimeters from D. So identify where's your vertex D. This vertex D, you measure 3 centimeters and you mark point P. So this 3 centimeters will mark here my point P, 3 centimeters from D. So that's step 4. Step 5, construct on the paper the normal end at the point P to the face DC of the block. Extend the normal to meet the line AB at R. Okay, I think you know what's a normal line. A normal line is a line that makes an angle of 90 degrees. That will make an angle of 90 degrees with the line DC. Okay, it means that at point P, I will come and place my normal here. Make sure that the normal should make an angle of 90 degrees. You can even use your protractor to make sure that. So this is where my line P should pass. So I'll have something like this. Then you should extend it until you come also on bisect line AB. So this is the line. This is our normal. We name it N. Okay. Then the next step, draw an incident ray to the left of P to meet the interface DC at P. Okay, where is DC? This is our line DC. I should draw an incident ray. We all know that word. Incident ray is a ray coming into the glass block. So the ray should be here. Now, initially you can choose any angle. You can choose any inclination. So I will choose it maybe to be. Let me choose any one. Let me choose this one as my incident ray. Yeah, I will call it I. Okay. Step 7, replace the glass block on the outline using the pins P1, P2, and P3. Trace the path of a ray of light incident on the interface DC through the glass block as follows. Okay, so this step is asking us to use pins for us to come out with a refracted ray. So we know that the incident ray will be refracted when we pass through the glass. So I will come here, I will put back my glass here, so they should occupy exactly the rectangle that we drew. Then I will use pins to determine the refracted ray. Then from there, we'll come out now with the line, the refracted line. So step 7, replace the glass block on its outline. So replace the glass block on its outline. Using the pins P1, P2, and P3, trace the path of the ray of the light incident on the interface DC through the glass block as follows. So insert 2 optical pins along the incident ray so that the pins are perpendicular to the plane of the paper. So I will come and put my glass block here like this. I will use 2 pins. I will place the pin so that the pin should represent my incident ray. I will place one here. Make sure that the pins are perpendicular to the plane, in fact to the sheet of paper. Then I will place another one here. Anywhere you want, you place it. It should be along the line of incident. Should be along the line of incident. Okay. Now the next step, observe through the face AB and insert a third pin P3 along AB so that P1, P2, and P3 appear to be on the same straight line when viewed through the face AD of the block. Okay, student, for us to place our third pins, we are supposed to align it exactly where the two pins showing the incident ray intersect. So while looking from face AB, we try to see where the two pins align as one pin. So let us see. When I'm going like this, through face AB, I'm seeing two pins. Then I try to move to the right. Yes, so that is it. When I try to move to the right, you will see that the pins through the glass block, you see that the pins align as one. Then you can now place your third pin so that it also aligns with the two first one. So somewhere here. So that is it. So this pin here will represent your refracted ray. So you indicate it on your sheet of paper. So that is it here. Okay, so then let us proceed with step 8. Remove the glass block and the pins, and through the refracted ray P2, P3 left, let the refracted ray meet AB. So I will remove my glass block here. Now don't remember that these pins represent our refracted ray. So I will remove the glass block. I'll use now a ruler. I will remove the pins. Like this. Then I will take a ruler now. From the normal here, I will join P to the point where we're having pin 3. So that is it. Okay. Remove the glass block and pins and draw the refracted ray P2 and P3. So this is our P2, this is P3, here was P1. So this is the refracted ray P2, P3. Then step 9, measure the angle of incident theta on the face DC. So you are supposed to measure the angle of incident. We all know that what? From the note, we all know that the angle of incident is the angle formed between the incident ray, this is the incident ray, and the normal, this is the normal. So they are asking us to measure this angle, and we record it. So we will measure the angle using a protractor. Now, how do we use a protractor? Our reference line here should be the normal. So I will align 0 of my protractor with the normal here like this, and the center of my protractor to where there is point P2, exactly like this. Then I'm measuring, this is 0, 10, 20. So 20, 21, because this is 25. So it means that the unit here is 1, So 20, 21. So my angle here is 21 degree. Instead you come and record it here, 21 degree. Okay. Next step, also measure H, the length QP of the refracted ray inside the glass block H. Okay. So we are supposed to measure the length H of the refracted ray. So we are measuring the line P2, P3. You take your ruler. I think to measure a line should not be a problem with you people. Then place here should indicate this point. I think is point Q, exactly the intersection of the refracted ray, because this is the refracted ray. Let me write it here. Refracted ray. Okay, where the refracted ray meets the face AB, you put your point Q. Now we are asked to measure the distance from P2 to Q. The distance from P2 to Q, that distance should be 6.2. And please, anytime you are using an instrument, you are supposed to use the unit of that instrument with its accuracy. So here the accuracy is 0.1, so I'll have 6.2 centimeters. Okay, students, let us proceed with the last step of the procedure. Step 10, replace the glass block on its outline. Vary theta by changing the position of P1 and repeat steps 6 to 9 to obtain other corresponding values of theta and h. Record your values on a table in the space below. Okay, now some can ask how many values or how many data we should come out with it. Look at, mark is indicated here 18 marks. It means that surely the table is 16 marks, so it means that you should come up with minimum 8 values. Yeah. Minimum 8 values. So before varying the incident ray, for us to obtain different angles of incidence and hence to obtain different values of h. So first of all, come and construct your table of values. So this is what you are doing in the exam, exactly as I'm doing here. At the beginning of your table, the 2 rows should be made up of your variables. Like, I'm varying who to have who. I'm varying the incident angle in theta. And when I vary the incident angle, I have directly the value of h in centimeters, because we are using the meter rule and the unit there is centimeters. Okay. After varying I and h, what am I doing with I and h? Look at step 11 is saying that plot a graph of sine square theta on the vertical axis against 1 over h square on the horizontal axis. It means that for my data, I need to have sine theta. Sine theta here is sine of what? Sine of incidence. I also need to have sine square theta, followed by I need to have 1 over h and 1 over h square. So this is how your table should look like. Now, as I was saying, look at the mark allocation is 18 marks. It means that you should come out with at least 16 values. 16 values to have at least 16 marks, because the other marks are, I think, it should be attributed to question 9 and question 1 that we will do later. Okay, so let me put it 1, 2, 3, 4, 5, 6, 7, 8. It means that we are plotting sine square theta against 1 over h square. So your table should look like this. When now you have your table, you come back on your setup. Yeah, you start with a new setup, so that you should start with a new angle of incidence that you are choosing, because here I need to come up with 8 values. It means that I can take my initial angle of incidence maybe to be, let's say 20 degree. No, let's say 10. Let's say 10 degree. Let me place my protractor. Always, the protractor should be aligned with the normal. So the 0 of the protractor should be aligned with the normal. The center should be here. If I start with 10 degree is here. Okay. It means that my first angle of incidence is 10 degree. So this here, without wasting time, you already know what to do. So no need to go and read the instruction again, no. You already know what to do. You're supposed to you put your pin P1 here, pin P2 here, then you place your glass block Now, with your third pin, you are looking for the refracted ray. And for us to have the refracted ray, we should align the two first pin on the same line with the third one while looking at the face AB of the glass block. Okay. Okay, student, as we did before, I'm looking the face AB of our glass block. Okay, I'm looking at the position where the two pins align as one. So as you are seeing here, you are seeing two pins. You are not seeing one, so you try to adjust until here. You are seeing one pins now. Exactly where you are seeing one pins, you should come and put your third pins. Here, you see that the three pins are aligned as one line. So you are seeing one pins because they are all on the same line. From there now you mark it and you remove your glass block straight. You form a straight line from pin P2 to the pin that you just putting. Okay, student, I now remove my glass block. I indicate my third pin. This is P3 here. This is P2. Without wasting time, you measure it. You first of all join the line. You join the point P2 and P3 together to form the line P2, P3, like this. Then you name this one Q. Then you measure the distance from P, exactly as we're doing. The distance from P to Q. When you measure the distance from P to Q, you have something like 6 centimeters. You come, you feel it, 6. No need to put centimeters. So we are having centimeters already on the table. No need to put it again. Then you measure your incident angle that we measured already. The incident angle was 10 degrees. 10 degrees. Okay, that's our first value. We do same with the others. So let me show you how to find how to align our third pin when we are at angle 60 degrees. You see that when the angle is increasing, the inclination of our refracted ray is also going to the right. So you are seeing here, you cannot really identify where the two align. You should go to the right again until try to see. Okay, from here we are still seeing two pins. If you go to the right again, here now you are seeing one pin. Look at here, you are seeing two. Make sure you are observing face AB. Don't observe what is on top. You are observing the face directly across behind the face. You are seeing two pins. Then when you are going to the right, it becomes now one pins here, two, here, one. Okay, when I go like this, it becomes one. So I'll align it here. So there is it. Okay, so this is our pin P3. We draw a line from P2 to P3. We measure the angle, but we measure the distance h from P2 to where it intersects. You see that it will be 7.56. Come, you report 7.6 when the angle goes to 60 degrees. So we are left now with two angles. Okay, student, these are our values that we obtained from the setup. So now, how do you know that your values are correct? You should have a constant variation. Like if the relation between I and H is direct, let's say when incident angle increases, h also increases, it should be constant all through. Like here, 10, when the angle is 10 degree, our h is 6, when it is 20, it is 6.1, when it is 30, it is 6.4. It means that as my incident angle is increasing, the value of h is also increasing, and it should be all through, there should be a constant variation between those values. Now, you proceed now to find sine theta, sine square theta, 1 over h and 1 over h square. And then we find the scale of the graph, we plot our graph, we come up with the slope. Okay, students, today we were focusing on completing part 1 of our experiment. If you want to learn how to use this data properly, how to choose a good scale, plot your graph accurately, and calculate your slope with ease, do not miss part 2 of this video. We are together.